Welcome back to the Foundation in C# course. We're currently in Module 3, and this lesson, we're going to cover handling exceptions. Starting off with, what are exceptions? Okay, so let's go over to our code window and go to File, New Project. We'll do a console application, the .NET Framework version. We'll call this Console UI. This is the exception handling demo. We hit OK. And the first thing we do is add our console.readline at the end. So let's talk about exceptions. The easiest way to understand an exception is to kind of see it. So I'm going to model that by creating some bad code. An exception is when code does something unexpected or something that is outside of what the processor or the compiler can handle. So let's create an array. So I'm going to say, let's call it, or let's just do a int array. And we'll say this is our ages equals new int array, and we'll put all three values right away. We'll say 1, 3, and 5, like so. So what that does, it creates a new int array where it has at position 0, it has the value 1. At position 1, it has the value 3. And at position 2, it has the value 5. Now, let's do a for loop where we say I is 1, I is less than. Normally what I do is say ages dot, like this, ages dot length. And the length says, okay, well, you've got 3 items in the array. I could do that. And in fact, you know what? Let's do that. Let's do ages dot length. But the reason why this less than is here is because remember, ages dot length is the count of how many values are in the array. In this case, there's 3 values. These 3 right here. But since it's 0 based, meaning we start at 0, it's 0, 1, and 2, not 0, 1, 2, and 3. That would be 4 values. That's why you do less than. But if I got confused and said less than or equal to, this is going to break. Just be warned, I'm intentionally breaking it. Let's see what happens. I'm just going to do a console write line that just has the value of ages at that spot. So it should say 1, 3, 5, and then we're not sure what's going to happen on the last one. Let's run it. Now, in the previous lesson, we talked about breakpoints. And a breakpoint would pause the code and give us this yellow box here saying, this is the line I'm on. But I didn't put any breakpoints here. So why is it here? Well, if we look at the console itself, it says 1, 3, and 5, which that's all 3 values in our array. But then what happened was we had an exception. An exception is something that is unexpected or it can't do. In this case, if we read this, it says system.indexOutOfRange exception. The index was outside the bounds of the array. Now, rookie mistake right here would be not reading this. I see a lot of young developers, newer developers, just skip right over this and say, oh, there's an error. And I ask, well, what was the error? I don't know. It's just an error. This tells you a lot about what the exception was and why it happened. In this case, it says index was outside the bounds of the array. Now that is seemingly insider speak. It's a little bit complex. It's a little bit hard to parse out. But if you take it word by word and look at it, index. Well, what's the index? The index of an array is that that value you put in this box here to say, find the value at this spot. So the index was outside the bounds of the array. So we're saying we're trying to use an index that's outside the bounds. What's the bounds? Well, the bounds are the lower end starts at 0 and the upper end ends at 2. Well, what's the value of I? If you can see that right there, it says the value of I is 3. That's outside the bounds of our array, which is from 0 to 2. 3 is outside that. So it told you exactly what the problem was. So that's very, very helpful right off the bat. Now, you can close this out. You can mouse over this if you want. You can bring it back up by clicking on the red X right there, or the red circle, the X in it. There's also more details possible with this exception. That's what this view details is. Now, Visual Studio has gotten a lot better in its error reporting to tell you much better messages. This is actually a pretty good message. Not totally clear, but clearer. It's definitely better than the errors we used to get that said things like an error has occurred. That's not helpful at all. Yes, we know an error has occurred. Where, why, what happened. This tells us that. Now, if you go to View Details, a lot of times these details aren't terribly helpful. It depends on the exception and what the reason for it is. I'm going to point out a few things that might be helpful, especially just starting off. Because again, we have tons of options available to us, but we really want to take the ones that get us the most value, especially early on in your development career. So the very first one you want to look at is the message itself. That's what pops up in this box right here. So the message itself says that the index was outside the bounds of the array. Okay, so that just tells you, all right, here is the simplest explanation we have for why this didn't work. That itself is usually enough to get you started. Now, next, we have some information in the inner exception. In this case, nothing, but it's good to look at. The inner exception says, well, maybe this exception was triggered by or has a parent exception. And if so, that would be in here. Now, if it did, and you expanded it out using this arrow over here, then you'd essentially have all of this information here with their values inside here for that exception. And in fact, it would have an inner exception, which could be null or it could be something else as well. So you can keep dialing through the exceptions until you get to the root of the problem. The final thing that you might want to look at is this thing here called stack trace. And what a stack trace does is it tells us where exactly the exception occurred. And it also tells us who called it and who called that and who called that all the way back through. So let's zoom out here and open up this stack trace and kind of expand it. Now, since we have a very, very simple application, it's not telling us a whole lot, but it says that console UI.program.main. Well, that's this namespace right here. And this is the method that it called, the main with string array of args in, and it shows the path to this application, to this file itself. In fact, the file is called program.cs, and here's the full path on my hard drive. And then it says at line 17. This is another reason why line numbers are awesome, because now, even if you didn't have the application paused right here, even if you're reading this later, you could open up program.cs and say, what's line 17? It's right here. So this is the line that had the problem. So now you know, okay, something in here is breaking my application. If your lines aren't huge with tons of different things on them, it makes it even easier. In this case, I'm pretty sure that console.writeLine isn't the problem. Microsoft debugged that quite a bit. So it's probably this right here, ages I. And since I also have the message that says the index is outside the bounds of the array, I can pretty much guess that I is the problem. In this case, I is 3, ages has 0, 1, and 2. So it really helps us to read this message. And I can't strongly enough say read the exception messages when you get them. Okay, so we have an exception in our application. Now I could fix this, but I really want to have this exception in order to play with it. I'm going to hit stop right now. Now ideally, if you can avoid throwing an exception, you want to. So, for example, maybe this value right here, instead of length, we ask the user, what number do you want to count up to? Which would be stupid because we only have so many values in our array. So that'd be a problem. But there's probably an edge case where that would make sense. In that case, it would throw an exception if they put a value that's too high. But I could do some validation on that data first and say, is that value greater than or equal to the ages.length? And if it is, tell them, no, you can't give me that value. So that would stop an exception from happening. But if there was a case where you really couldn't on your own prevent an exception from happening, then what you can do is you can wrap your code in what's called a try-catch block. So I'm going to show you wrapping code in a try-catch block, and I'm going to do it a couple different ways. The first way I'll do it is I'll do it manually by writing try and put my code in there and doing catch. And then I'll show you wrapping this existing code easily. So let's start with cutting this out, and then I will put the try catch in. So if I type try and then tab twice, that uses the snippet for the try catch block, which that's this right here. And it says try, and it has curly braces, and that has catch, exception, has curly braces, and a throw in here. So let's talk this through. First of all, this is where our code goes, inside the try. And this reads pretty much like normal English. Try to do this. If it works, you're good. Don't do the catch block. But if you have a problem, you throw an exception, catch that exception. In this case, we're catching the exception. And then we're going to run this code. So let's wire this up to catch our exception we know is coming. So the catch block, we can take this off if we want to and just say catch. This and goes, oh, well, that's what I do. And it's no longer in an exception state, meaning it's no longer unsure what to do next. It knows, okay, I can print that out instead, no problem. And then I can move on. In this case, go up the top again, find that we're done, and move on to the read line. Now, what's the problem with this? Well, we've just eaten our exception. That's the kind of the non-official term for it, eating our exceptions. What that means is that we caught an exception and we kind of just, picked up the corner of the rug, shoved it underneath, and put the rug back down and said, you didn't see anything. That's not good. And the reason why it's not good is because an exception happens when something unexpected occurs. Well, if it's unexpected, then our application is doing something weird. You don't want your application to continue running if weird. The other thing is we said we have an error, but what error is it? We don't know. So let's make this a little better. Now, originally, we had in parens exception here. And that's fine, but the reality is that just says catch any exception, which is what you want. But in this case, I want to put EX after it. Now, EX is an unofficial standard for the name of an exception. And so what happens here, if you notice, it looks an awful lot like a declaration of a variable. Exception, EX. And that's exactly what it is. We're declaring the variable EX and saying, if you catch an exception, put that exception value in EX. Now, what does that do for us? Well, instead of saying we had an error, we can give an actual error message. So console.writeLine, I could have done CW tab, just forgot. I can say EX dot, and I have a whole bunch of options here. And one of the options, let's get back to that list. One of the options is message. And that's, like I said before, the most valuable piece because it's the most clearly stated reason why we had an exception. That's the one that says the index was out of range for the array, or out of bounds. So I can do this. And now if we run this, we get we had an error. The error was index was outside the bounds of the array. At least now we're saying why the error occurred. But if we were writing these values to a log file so that later we can come back through and figure out what went wrong, guess what? That's not enough information. Because if you see that error, you don't know where that error occurred. So if you're writing to a log file, you might want to do this instead. Just write EX instead. So I run this again. Notice it says system.index out of range exception. Index is outside the bounds of the array at, and it has the path here, and then it has the line number as well. So that's more information that your logging system might need. Now, it's not the information that a user would need. Almost certainly a user doesn't or shouldn't know where in your application that error occurred, what line it occurred on, or anything about your application's internal workings. So that's more save it to a log file. ex.message might be more appropriate for showing a user. It's not great, but it's not horrible either. Now we're still just eating this exception. We're not doing anything because of it. And this is where we have a few options. We could adjust something in here. So for example, we could change the value of I, or we could go out and do some backup routine. For example, where maybe this is loading a file and it fails, we could, the fallback would be to load from a local file instead of that remote file or something like that. So there's options here, or what we can do is we can do what was in the template, the snippet we created, which is to throw. And what this does is it says, okay, you caught an exception. You did something, maybe you showed the user or something else, but now you want to keep going as if that exception was never caught in the first place. And that's what throw does. Throw says, okay, we caught this exception, now throw it again and pretend like it was never caught in the first place. Let's see this. You see there, it says index was out of range exception, index was outside the bounds of the array. And if you look at the details, we can look here and see all the information, including the stack trace. It says at line that's on, which would be line 13. Okay, so we hit OK. Actually, if we go here, line 13, but then line 32 up here. Why? Because I'm actually calling a method. So notice here, the top one is the bad call method, and it occurred in line 32. But next it says the main method, it occurred on line 13. What does this mean? Remember I said this is a stack trace. So the most recent call is on top, but then its parent call, if there is one, is below it, and its grandparent call is below that, and so on. So in this case we have two. The bottom one is line 13, which is right here, where we made the call to the bad call method. So you can kind of walk back the chain to where this was originally called from. Now it does say line 32, which is the wrong line for us, and we'll address that in a minute. But for now, we have this exception occurring down here. Why does this help us? Well, we can actually put a try catch up here. So remember I said before that I cut out that line and did a snippet and then pasted my line back in, but there's another way of doing it. Well, this is the other way. So if you highlight whatever code you want, one line or many, right click on it and say snippet, surround with, and then type try and tab. Notice that bad call is now inside of my try curly braces. And then put the snippet around it. So now with this wrapped, I can say console write line, there was an exception thrown in our app. And maybe I leave it right at that. Or maybe I do the ex.message. But either way, now I have 2 try catches. Let's run this. Notice it says we had an error. Index was outside the bounds of the array. There was an exception thrown in our app, and index was outside the bounds of our array. What happened? Well, when the exception occurred down here, it got caught in the catch. It printed out these 2 lines, and then it said throw. And remember, throw says, okay, treat it like it never got caught. And so it throws an exception. Exceptions bubble up, meaning if you don't catch it in bad call, whoever called bad call has the opportunity next to catch it. And it goes all the way up through and nobody handles the exception, then it's an unhandled exception. But in this case, bad call is wrapped in a try catch block. Therefore, we have the opportunity to catch it right here. And we did. So now we have 2 try catch blocks working for us. Why do I have both? Why would I ever do 2 catch blocks or 2 try catches? And the reason why is because you want to do something in the catch. So inside this bad call, maybe I want to log this exception or do something else with it. Like I said, have a fallback value or change the value or in some other way do something to this code or the situation. But then I want to throw it again because I want to allow my user interface to tell the user. Now we're in one big user interface project, so it's a little bit less necessary. But when you're talking about having code buried way down in a library somewhere, that code can't talk to the user directly because it's not user interface code. So you allow the exception to bubble up to what is user interface code, and then it can tell the user, hey, there's a problem, and then do something else if it wants as well, and then finish handling the exception. So what that means is if we didn't have something to do down here with this exception, what I would do is just take it out. And you might say, well, but that throws an exception. Absolutely it does. But that's okay because up here, I have my code wrapped in a try catch. So if I hit start, no exception because actually it was an exception, but there's no unhandled exception because it caught it. It told me there's an exception and it told me what the exception was. Now, let's go back and address that wrong line number. So I'm going to hit Control Z here to undo my changes down here. So now I have my try catch down here. Remember, this throw causes a problem where it's putting the wrong line number in. Now, one of the things you might see in some examples is throw EX, because this is an exception, right? So therefore I can throw it. Let's look at what that actually looks like when we catch it. If I mouse over this, it causes a problem in here in my stack trace. It says line 40. So here's our exception. And if I look at the stack trace, it says line 50 and line 40. That doesn't seem to help me. But then if I mouse over and look at my inner exception, notice that, and I'll zoom in here. Oops, wrong zoom because that zoom doesn't do it. Inner exception says that it has a value and it's not null anymore. The inner exception has a stack trace, and that stack trace says at line 34. So let's look at line 34. Line 34 is this line right here, the original line that had the problem. So if you want to catch an exception down lower, but then rethrow or throw the exception again, it's usually better, in order to capture all this stack trace information properly, to throw a new exception, give it a message, and then pass in the exception that you caught. Now let's talk about some best practices here. If you notice here, I have a whole bunch of code, but my try catch is only around this one line of code. I could have put all this code inside of my try. Why didn't I? Well, it gets a little bit more expensive to do so. So you want to laser focus in on where there could be an exception and just wrap that in a try catch. Okay? So now notice if you mouse over console right line, it has this message that says exceptions system.io.io exception. So console right line says there's an opportunity for me to throw an exception. In this case, there's one exception it can throw, system.io.io exception. That means, in theory, data I pass in here could cause this issue. Does it happen very often? No. Is it very rare circumstances? Yes. So I don't wrap all of my console write lines in a try catch, because again, there's a little bit of overhead when it comes to using a try catch. So I only focus in on where I think there will be an issue. This is where debugging comes in. This is where knowing how your application is going to be used comes in. And this is where thinking ahead really comes in, because you have to make sure that you validate your data, meaning you check your data to make sure it's right when you get it from an external source such as a database or a user, especially a user. Because bad data is the number one cause for exceptions. And that's my statistics. I'm not sure if the actual math on it is true or not. From what I have seen, that's the number one cause. So if you do that, you eliminate the biggest issue. There are still times when there might be an issue. For example, if you are writing to a text file, maybe it goes away all of a sudden. Maybe you're writing to a text file that's on a thumb drive. The thumb drive goes away, or the USB drive goes away. Well, that might throw an exception. You might want to prepare for that and catch that exception. So there are times to wrap something in a try catch, but try and limit it to just the cases where you can't help an exception. It's outside your control. You can't just check in some other way. But when you do, just wrap just the code you need and only handle it at the point you need to. So down here, if I'm just writing to the console, I don't need to handle it down here. Let it handle it at the very top. And this is something else that newer developers sometimes struggle with. And that's the idea of being scared of exceptions. Don't be scared of exceptions. Exceptions are a normal part of the application. They're a part that needs to be there. So if you have an exception in your application, embrace it. Figure out where you should catch it. figure out if you should catch it, and figure out what to do when you do catch it. So in this case, usually what I do is I catch at the very, very top of my application, meaning the user interface. And the reason why is because at the user interface, I have the ability to talk to the user, to get their feedback, and do something about it. I usually also log that exception so that I can later review those logs and say, okay, here's how I can make my application better by fixing these bugs, if they are bugs. The other thing is, don't just catch every exception and then allow your application to continue. There may be a case for you to stop your application. If you're getting consistent bad data, then there's a problem somewhere. And if it's threatening your application or it's threatening to cause your application harm, close your application. It is much better to close your application rather than try to limp on with bad data flowing through your application. So just know that it's okay to close your application sometimes. Okay? So that brings up our tips. The pro tip for today is don't blindly catch and ignore exceptions. That means that you want to think through when you catch exceptions and what to do with the exceptions when you catch them. And then the second half of this is don't be afraid to close the application. Again, this is one of those rookie mistakes you can make, is that you want the application to never crash, never close. Don't do that. If it's in a bad state and something weird's happening and you don't know why, then close the application. Okay? So here is your homework for today. Create a console application with a for loop that throws an exception after 5 iterations. This is going to use a couple different pieces of your previous learning knowledge, which is good because it kind of builds on each other. So create a for loop that throws an exception after 5 iterations, meaning 5 times through the loop, and then catch the exception. All right? And then put a breakpoint on there and just look through the data of it. All right? So that's your homework to do before you move on to the next lesson.